Okay, so from here, as you can see from my drawing, just about everything is there. Like givens, well, not all hiddens. Like acceleration is like -10 meters per second squared, right? Also, something like at the top here, VF is 0 in the y direction. Also over here, Vx is going to be constant, and then that will be Vy. So I put just about everything on my diagram. Okay, that's up to you whether you want to do that. I don't want to have to write the Gaia stuff, but you can still do that. So I just need to find what is the y here. Do you see that this is kind of like a fence problem? Right? Except it's even easier because they already gave me the time, right? So all I need to do is say what describes the position. Well, there are two equations that I told you that you use for all of these. Whoops, just kidding. X, Y, that makes a lot of sense. Right, there are two equations that you use for everything. Also remember that I told you you have to crack the vectors right away. So this is 30, this one becomes 15 meters per second, and this becomes 26 or something? Yeah. I'm just gonna round it to 26 to make my life easier. So then here, to find y, all I have to do is plug this in. Right? So I get 26 times 4 plus 1/2 times -10 times 4 squared. And so that's 104 minus 60, what, 80? And then that makes 24. So we get y equals 24 meters. Okay, pretty straightforward. Oh, okay, good. I'm glad. I'm very glad for you. So now we have to use a piece of hidden information, which we've talked about before, and that's at the top of this thing's highest projectile. Yeah, the y velocity. Careful though, the x velocity hasn't changed. It's still, wow, why did I write? Yeah, it's still 15 meters per second. Okay, so at that top, it's still 15 meters per second horizontally, but vertically, it's 0. Shh, this is recording the sound, so if you jabber too much, it makes a lot of noise. So it's still 0, and it's 0 in that respect. So then what I can do is, since I have the initial vertical velocity at 26, I have the final vertical velocity, and I have the acceleration, and I want y, I'm just going to use vf squared equals v0 squared plus 2ay in this respect. So y is going to be equal to vf squared minus v0 squared all over 2a. That, of course, is 0, and you get 26 squared over -20. And I don't know, 25 squared is 625, so it's going to be around 30-something. I'm guessing around 33. So this is around 33 meters. V naught is V naught squared, yes. No. 26 squared is around 600. Yeah. Because that's the initial velocity, vertically. Remember, I'm looking at this only in the vertical direction right now. Why should I? They just asked for the highest point.
Hey, how do you get 26 vertical velocity? How do you get that?
Sine 30, sine 60. I hope it's 26. I used I was guessing in my head, so. Remember, I'm using rough numbers here, so I'm rounding everything off. Yes? Shh, please, may I ask a question? Why did I use this equation? Well, this is on your formula sheet, isn't it?
Oh, yeah, I know.
Yeah, but because I'm trying to find the height. So in the least thing, if I have no idea what to do, look at my formula sheet and say which ones have y in it, right? And then I ask myself, of the ones that have y in it, which ones do I have the most information? So if I look at this one, do you see that for the maximum, I know that at the maximum point, the y velocity is 0. So that's v final, and that's what helps me, because I know v0 and I know a. So by using this equation with that piece of hidden information, I can find y. Other questions? Yeah. Where this? No? If it's t, you're thinking of vf is equal to v0 plus at. Yeah, which we actually will use in just a moment. Questions? Nothing, hang on, I'll show you. Any other questions on this part B? Yes? Yeah, but we're assuming y0 is 0. Like, I'm assuming that it started on the ground and my frame of reference puts the ground at 0. So this is technically delta y. So, but you see delta y is just y. So yeah, if you want to put delta y, that's fine. Okay, questions? All right, yes?
Delta y is variable, and does it affect the calculation?
No, because y0 was 0. Now, if you were doing this problem off of a cliff that had a height of y, then you have to be careful. Because delta y will only give you how high it goes above. Right? Yeah, so you just have to pay attention to that. All right, finally for the last part, I need to know vf, and that's going to be the square root of vx squared plus vy squared at this point, right? Do you get what I'm saying there? Now, we know one of these, which is? Which one do we know already? We know Vx, because Vx is always the same. From the moment this projectile got launched until the moment it hits the ground, Vx never changes because we don't use air resistance. Vy changes, right? In fact, it's initially vertical. When you get to the maximum height, which we calculated in B, Vy flips from being positive to negative because now the thing's falling, right? So all we have to do is say Vy is equal to V0 plus AT. And of course, this is V0y, right? And that was 26, right? So it's 26 plus negative 10 times 4 seconds. So that gives us negative, what is that, 14? Negative 14 meters per second there. So here we have 15 meters per second and then 14 meters per second. So I don't know, whatever, which is going to come out to be around 15, right? So it's 225 plus 196 and blah, 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 whatever that comes out to be. What does that number come out to be? 20.52? That's interesting, isn't it? Yeah, I guess that's right, yeah. It should be. Oh yeah, it's not 50. It should be like 15 times, almost the square root of 2, yeah. 1.4, yep. Okay, questions? Yeah. Shh, please, please, please. Listen to the questions, thank you.
So for gravity, you always use
Well,
negative?
which way did this thing move initially? Does that make sense?
But if it's going down after, you still use
Yeah, because this takes into account the initial vertical velocity. See that? This is the thing right here. This 26, that locks you in. That says up must be positive.
Okay, so if it were falling from the start, you would use positive?
Sure, you could, yeah. I'm not saying you have to. You can still use negative, that's fine. You know, if you use a tabletop problem and you have gravity as negative, you just have to remember to use the height as negative. Because then if you use gravity as negative, then you're saying like, I start up here and I fall down. So everything below me is negative, everything above me is positive. But yeah, it's all of that is frame of reference. You can do it however you like. Yeah.
I have a question. It's kind of like not related.
Well, okay, hold on to it then. Any other questions about the problem? Yes?
I just stopped at the negative 14, but why did you go?
Because negative 14 is just the y velocity. Right? There's still an x. The whole time there's an x. Because, look at it this way. Which way is this pointing? No, straight down. Because what is the only acceleration affecting this? Gravity, right? So Vy is pointing straight down. V final is at an angle, and it is made up of Vx and Vy. Do you see what I'm doing there? So this part that you calculated was just the vertical velocity. The horizontal velocity we already knew. That never changed from the beginning. So you have to combine those two. See, this doesn't take into account the x value at all. So in this case, it's just going straight down. But we know that it has this horizontal, so we have to take the horizontal plus the straight down, and we get VF. Okay, any other questions? Does that help at all?
Yeah. But like, I was thinking like it's impact speed, so it just counts for only y.
Well, when I asked you what's the final velocity, I meant what was the final velocity in the y, but your hand went like this. So you realize that when that thing hits, impacts, it's going down and into the ground, right? It's not going to go boom and then hit like this, right? If that was true, then a cannonball could land right in front of you and you would have no danger, right? Because it would just go boom right into the ground, straight down. But we know that doesn't happen. If it lands in front of you, it's going to like bounce and hit you. It's going to throw everything this way. Does that make sense? Yeah. Okay, any other questions?
So in other words, in order to find V final, you have to use the Pythagorean theorem.
Yes, we were using the Pythagorean theorem, which is nothing more than adding up two vectors.
And we find Vy by using the initial velocity plus acceleration plus time.
Yep, that's it. Well, not acceleration plus time, acceleration times time.
Acceleration times time. And we notice 26 because it's
We cracked the vector.
the vector during each second and that's sine.
Okay, so in case you weren't listening, like what Elsa did is pretty important. You need to make sure that you can backtrack through the whole process, right? That you can go from one step to the next step to the previous step to the previous step, and at each step, you know why I chose what I did. That's very important. All right. Okay. Any other questions?